All right, we're going to graph some polynomial functions. Before we start graphing a polynomial function, we kind of need to know what a polynomial is. Let's take a look. Okay, here's an example of a polynomial. A polynomial is just a string of terms with exponents. The highest exponent of a polynomial is called a degree. So the degree of of the polynomial is the highest exponent. And the number in front of the highest exponent is called the leading coefficient. So the leading coefficient and the highest degree. Now both of these pieces of information are going to be used when we find end behavior. Okay, end behavior is going to derive our function. That's really going to show us what it is that we're looking for. And we're going to be using the degree and leading coefficient in order to come up with that. And we're going to come up with this test. It is called the leading coefficient test. And it looks like this. Okay, so I told you about the degree. So the first thing we're going to look at is the degree. If it is odd, so that means the highest exponent is odd. That's what our degree is. And then the a value, now just like when we were talking about quadratics, which a quadratic is a polynomial because it's just a string of terms. So the a value is always the leading coefficient. So your a is the leading coefficient. And that's what we're looking for there. If a is greater than 0, what does that actually mean? Yep, it's positive. Good. Therefore, if a is less than 0, what does that mean? Yeah, negative, because negative numbers are smaller than 0. Good. So those are my two categories. Now here's the deal. Whenever I'm looking at my end behavior, if I have an odd degree, my end behavior of my polynomial is going to go in opposite directions. So it's going to start down. Some crap's going to happen in the middle. We don't know. And then it's going to go up. The only thing I'm concerned with in behavior is what my arrows are going to do. It's the end of my polynomial. If I have it positive, it's going to end positive with opposite directions. Just like if I have negative, it starts up, some crap happens, I don't know, and then it ends down. So it ends in the negative direction. Cool, let's check this out. Okay, so we can have an odd degree or we can have an even degree in the same categories. So an even degree, the same thing. So my highest exponent is going to be even. And then the a value is still the number in front. If a is greater than 0, still positive. If a is less than 0, still negative. So then the deal with even degree is they're going to go in the same direction. So think about a quadratic and what we already know. If I have so my even degree is a quadratic, that's squared. If my number in front is positive, what does it look like? Yeah, parabola goes up. So any even degree, it's going to be on the up and up. It points positive. If it's negative, yeah, so my negative a value, that is reflecting. So whenever we did our quadratics, that's what reflected over the x-axis. And so they're both going to point down. And that's true for any even degree. So odd is opposite directions. Even is the same direction. Cool. Let's try a couple for examples. All right, check this out. Here's example 2 out of your book. Again, I just took a picture so that we could see this. We're going to match the function that we're given, this f of x, g of x, h of x, and k of x, so these functions with the different graphs. And the only thing we're going to be using is end behavior to do that. We're not actually going to graph this stuff. We're just looking at end behavior. You can identify graphs simply by end behavior, which is pretty cool. Okay, so let's look at this f of x. I have x to the 4th, which is even. So what do we know about my end behavior on even? Yep, same direction. So anytime it's even, you know it's same direction. The big question is it same direction up or same direction down? And how do you determine that? Yeah, if it's positive in front, which this one is, because if there's nothing in front, it's an automatic 1. So a positive 1, even, so it's on the up and up. Which one is that, A, B, C, or D? C. Good. So f of x here is c. Awesome. What about g of x? What do we have going for us there? Here I have a negative x to the 6th. So x to the 6th tells us same direction, good. And that negative means, how are we going with that same direction? Down, rock on. So A, B, C, or D? That's an A. You guys are so awesome. Good. And notice, have we graphed anything here? No. If we've plotted points? No. You can totally see what your graph is going to be just by the end behavior. Cool, let's do more. Let's check out this h of x. What do we have going there? I have a 3x cubed. So the x cubed simply tells me that it's odd. Now the lead coefficient, that 3 in front, has nothing to do with the direction. I don't care what that number is. I only care if it's positive or negative. It could be 50 billion x cubed for all I care. Just whether or not it's positive or negative is the kicker. Good. Now the 3 exponent tells me that it's going in opposite direction. The positive coefficient tells me that they're going in, ending on the positive. So A, B, C, or D. You got it. You guys are so good. It is totally B. And that is our h of x. Right on. Well, by, process of elimination, I think we all know what k of x is, but let's look at it anyway here. So we have a negative, who cares what the number is, simply that it's negative, and my exponent is odd. So it's going to go opposite direction for odd, and negative means it's going to end on the negative, going down. So k of x, very good, is a D. Cool. Now let's put this into practice by graphing a couple of these bad boys.